because we're moving on. We're into 2-5 now. So we're going to be solving absolute values. This is old school. You've done this before. This is 2.5. So I'm going to bring it in here. Remember, absolute values are a way to mark the distance. So this means that the distance is 9. I always think of absolute values as my watch. It does not care if I go 9 steps that way or if I go 9 steps that way. It's 9 steps because I can't unstep a step. I cannot take negative 9 steps. I can go 9 in that direction, totally fine, but it's not negative 9 steps. So what this means is this value inside, that x plus 7, could equal 9, and those absolute value bars might not be doing a dang thing. Or x plus 7 could equal negative 9. And those absolute value bars are changing that negative 9 to be the distance. That is the word or, not a picture of a mouse. There we go. I was like, y'all will learn very quickly that if I had tried to draw a picture of a mouse that lovely, would not happen. Okay, so then we need to finish solving these for x. What do? Subtract 7 on both sides. So we get that x equals minus 9 minus 7 gives us 2. Or x equals minus 7 on both sides. Negative 9 minus 7. Negative 16. So what we do with absolute values when we have stuff outside is we get the absolute value by itself first. You cannot distribute into an absolute value. So we isolate our absolute value, then split it into cases. So I'm just going to draw a little barrier here. That is not a math thing. That's just a visual barrier so we can tell the two dang equations apart. So let's do this next one. I need to get my absolute value by itself first. Think of it as a little jail cell. I cannot get things in or out of the box. Do not put things in. Do not take things out. Get the box by itself. What do we do to get the box by itself? Eventually, but what are we going to do first? Add 8. So we're going to have 3 times the absolute value of x minus 4 equals 10. Then what do we do to get the absolute value by itself? Divide by 3. Get the absolute value by itself first. So we have the absolute value of x minus 4 equals 10 thirds, which is gross, but fine. Now I can split it into my cases where x minus 4 could absolutely equal 10 thirds, and those absolute value bars could be doing nothing. Or x minus 4 could equal negative 10 thirds. So then what are we doing to both sides? Add 4 to both sides on both of these. So if we add 4 to 10 thirds, 22 thirds. Because to get 4 to a common denominator, 4 in terms of thirds is 12 thirds. 10 thirds plus 12 thirds. 22 thirds. So then again, we're going to add 4 over here. 2 thirds. because 4 is still 12 thirds. Negative 10 plus 12 gives us positive 2 thirds. Because we're adding 4 to both sides, the whole number of 4. To add our pieces together, we have to have common denominator. 4 in terms of thirds is 12 over 3. 12 thirds simplifies down to 4, right? So 10 thirds plus 12 thirds gave us 22 over 3. So when you have fractions to add or subtract, get to a common denominator first. Okay, one more absolute value. Because this 2, 5 goes through solving in like 8 different kinds of things. So, barrier. Let's solve this one over here. What are we going to do first? Add 4 to both sides because I need to isolate my absolute value. So we have negative 2 times the absolute value of x plus 8 equals 10. Then what? Divide by negative 2. Absolute value of x plus 8 equals negative 5. So my distance is negative 5. Remember, absolute value is the distance? Can we have an absolute value that's negative? Because I cannot unstep 5 steps. Doesn't matter which direction I go, I cannot unstep them. So what does that mean? There's no solution, extraneous kind of. It's not technically extraneous because we don't have a solution to be extraneous, but I get the vibe. No solution. Same vibe, different flavor. Yes, dear. Because I cannot have a negative distance. I cannot have a negative absolute value. I will never equal a negative number when your absolute value is isolated. It can have negatives all over the place until we're isolated on an absolute value. So distance cannot be negative, so it's no solution. Questions on the absolute values, because we're going to move on to other flavored things. We say why? Because 2, 5 goes through absolute values and factoring and square roots and fractional exponents. All on solving. Yes, dear. This is 2, 5. Yes. Yes, I can hear you. I was like, somebody said, can you hear me? I can hear you over here. All right. So here's our next one. We're solving again. Solving means we're getting all the way down to x equals. That is the goal. This is the goal. We need to get to x equals, not x squared equals, x equals. So we have 9x cubed minus 18x squared minus 4x plus 8. The book does highly recommend grouping here. It is doable with a box. It's not pleasant, but it's doable. I prefer grouping. It takes less space on the paper. I feel like it's very logical. It's more useful in some things. But if you are a box stan, go for it. It works. You just put each term in one box of your box. Okay? So I'm going to do this with grouping, where I break it into pairs. And we are going to factor out a common factor from both pairs. What is common between 9x cubed and 18x squared? 9x squared. And what's our remainder? X minus 2. What is a common factor between minus 4x and 8? Negative 4. So whenever you have a minus in the middle, you're going to pull that minus. So we're going to pull the minus 4 And it has a remainder of x minus 2. Those two pieces need to match. Our what's left overs need to match. If it helps, think of it as now factoring out that x minus 2 term. X minus 2 times the grouping of 9x squared minus 4. I still see a power in there, so we need to keep trying to keep going. So I still have an exponent on an x. So what can I do to simplify 9x squared minus 4? Confidence. Difference of squares. You said it real quiet, but you are absolutely right. This is a difference of squares, which I tend to just say DOS because if I write difference too many times, we'll get a random number of F's in it. Because I don't know how to spell it. So I'm just going to drop that x minus 2 down. What do we get when this difference of squares happens? Plus 2 and 3x minus 2 equals 0. Okay, so this difference of squares gives us these two terms. What are our solutions?
X equals 2 and x equals plus or minus 2.
X equals 2. This one is x equals minus 2/3. This one is x equals positive 2/3. I'm absolutely okay with plus or minus 2/3. Totally fine. The way we found that is we take each of our terms. 3x plus 2 equals 0. Solve for x. 3x minus 2 equals 0. That's how we found those. We are going to be working with finding solutions in pieces of what we're doing for the next rest of the chapter. So we're going to be finding solutions. So being able to do these as close to in our head as possible is going to be handy when we start getting into some of the grosser things next week. Or actually, I think by the end of this week, we start getting into really wanting to be able to do this in our head as best as we can. Okay? Not the all of this in our head. Whoa, not the laser pointer. Not the all of this in our head, but just like this step, being able to do from here down to here as best we can. Okay? So our next one is 4x to the 4th plus 10x cubed equals x squared minus 15x. What do I need to do first? Bring it all to one side, set it equal to 0, however you want to think about it. Because we got to have them all together before we can factor stuff. So 4x to the 4th plus 10x cubed minus 6x squared minus 15x equals 0. Do not drop the equal sign because we scooched stuff over. The equal sign is there. The equal sign stays there. I'm going to do this with grouping. If you want to box it, again, it's doable. It's not pretty, but it's doable. Bust it into pairs. I always like to put that minus sign in there and put a plus in between. It helps me see stuff easier. So what is common? Ooh, actually, we have a step before that. What do we have that's common in all 4 pieces? X. So we got to check that first. I 100% missed that one. 4x cubed plus 10x squared minus 6x minus 15. Now we can break it into pairs and do our factoring with grouping. So we got to check that first. GC up first. So that x out in front's just going to hang around for a while. What do we have that is common between 4x cubed and 10x squared?
2x squared.
2x squared. And our remainder is 2x plus 5. What do we have common between minus 6x and minus 15? Minus 3. Leaving us with 2x plus 5. And close the blue one equals 0. So we have x times, let's see, I'm going to put the big one first. 2x plus 5 times 2x squared minus 3. Is this difference of squares? No. So we're going to do this a different way for solving. I wasn't doing that. I didn't touch it. I didn't touch it. Not until I closed the box. If I get within an inch of the screen, it thinks I've touched it. All right. So let's find these solutions first. What is the solution for this one? X equals 0. What is the solution for this one? Negative 5/2. What we do for this third one is we're going to set it up. 2x squared minus 3 equals 0. Get the x squared by itself. So we're going to have 2x squared equals 3. Add 3 to both sides. So x squared equals 3/2. So what does x equal? What needs to be in front of it? Plus or minus square root of 3/2. Whenever we are taking the square root of a perfect square like this, you got to include that plus or minus. Because we have here our original equation is a to the 4th. Which means we need 1, 2, 3, 4 solutions. Okay? Questions on those ones? On our with grouping stuff. Because we are next going to play with some scary looking things. Fraction the exponents. They look scary. Rational exponents, they are both fractions and exponents, and we get a little overwhelmed sometimes. So I'm going to zoom it in. We have x to the power of 3/4 equals 125. There are two ways to think about x to the power of 3/4. We can think of it as x to the 1/4 cubed or x cubed to the 1/4. Because remember, whenever you have a power of a power, you can do that. So this is really the 4th root, right? How would I undo a 4th root? To the 4th, right? Yeah, I got the vibe. If I do to the 4th on both sides, is this going to be something I can do something with? Or is it going to be obnoxiously long? Obnoxiously long. So look at this side. If I have x to the 1/4 to the 3rd, how do I undo to the 3rd?
Cube it.
Cube root it. Can I cube root this? Yeah, so let's go with that side. So we're going to do the cube root of this and the cube root of that. The cube root and the cube cancel out, which is going to leave us with x to the 1/4 equals, what is the cube root of 125? 5. Okay. So how do I undo the 1/4 again? The 4. Power of 4. Raise both sides to the 4th power. To the 4th. To the 4th. So we have x equals 5 to the 4th. I was going to say, remember 125 was 5 to the 3rd, so 125 times 5? 675. 25. Totally. Shush, it's a 2. We're just pretending that I did not write a 7 first. There. That's why on my Z's I always put that little crossbar, because sometimes my 2's look just like these. Okay. So we're going to think about fractional roots kind of as pieces or as products of whatever the numerator is and whatever the denominator is. So it's less complicated when I just have a number on the other side. This middle guy, y to the 3/2 equals 5y. Now I got variables on both sides, which means it needs to equal what before we start trying to factor stuff? 0. So we got to get that 5y on the other side. So we're going to have y to the 3/2 minus 5y equals 0. Can I take a GCF out of any of those? Y. They both have y's in them. So if we factor out a y, how many y's are left if I take y out of y to the 3/2? If I take 1 out of 3/2, how much is left? 1/2. Yeah, square root. Y to the 1/2. Minus, what's left on that? 5. So we wind up with our solution being, we've got y equals 0 here, and y to the 1/2 minus 5 equals 0 to find our solutions. So we got to get this down to y equals. So what do we do? Add 5. Y to the 1/2 equals 5. What do we do to get the 1/2 out of that exponent? Square both sides. Or to the 2, however your brain does it. To the 2nd, to the 2, square. I don't care how you word it. English is a suggestion. So y equals 25. Yes, dear. Because we took 3/2 and we pulled 1 out. So y times y to the 1/2 gives me y to the 3/2. So we're kind of factoring out a 1 y. So 3/2 minus 1 leaves you with 1/2 left over. Okay. I'm going to give us a little barrier here because I feel like these are all kind of blending together. I'm just separating those so we can see what's different. Okay, so then we have one more like this. Okay, so we have x to the 3/2 equals x to the 1/2. So again, I've got variables on both sides, so we need to make it equal 0 first. So we're going to have x to the 3/2 minus x to the 1/2 equals 0. First thing first, make it equal 0. Then see what we can factor. What do they both have? X to the 1/2. When I factor x to the 1/2 out of 3/2, what do we have left over? X to the 3/2 minus 1/2. 2/2 or just one? When in doubt, write it down. Minus x to the 1/2. When we factored out 1/2, not x, just 1. When in doubt, when you get here, redistribute it and make sure you get your original statement back. If I distribute x to the 1/2 times x, we'll get x to the 3/2. If I do x to the 1/2 times minus 1, you get minus 1/2. So if you're not sure if you did it right, redistribute it. And now we have our possible solutions here. So we have x to the 1/2 equals 0. And x minus 1 equals 0. So what are our solutions? X equals 1. And then if I square both sides, we get x equals 0. You can always bring them up here and test them out. Square root of 1 is 1. Square root of 1 cubed.
Oh, yeah, we could have just thought about that.
But you can't always necessarily do it by thought.
Yeah.
But yeah, the only thing, the numbers cubed, that their square roots are the same. It's just going to be 1 and 0. Oh. Okay. Questions on these? Because we're taking these and we're going to kick them up a half notch. This is the last slide. Okay? Last one. This is the last one for today. So these two are the last ones, okay? So now they've got radicals in them instead of just fractional exponents. Yay! So what do we need to do here to undo the square root? Square it, right? Undo a square root, we're going to square both sides. That cancels my square root and my square out, so we get 2x minus 9 equals what? 1/3 squared, which is 1 over 9. 1 squared over 3 squared, which is 1 over 9. Then what do we do? Add 9. So 2x equals 9 and 1/9.
82.
82 or 82 ninths. Get x by itself, divide by 2. What do we get? 82 over 18 is valid. Can we do it a different way so it simplifies? What's 82 divided by 2? 41. (82/18) also is valid, but you then have to simplify because they're both divisible by 2. I always recommend, we need to go through and double check that this is not going to give us a negative under the square root, so we do need to check it. So if I take 41/9 times 2, that gives back our 82/9, which is 9 1/9 basically. Minus 9, is that a positive number under that square root? Yeah, it'll be 1/9, but it is positive. So as long as what's under the radical is a positive number, it doesn't matter what it is, we're fine and it checks. We just cannot wind up with a negative number on these solutions because then it's not a real solution, it's an imaginary one. So we're checking to make sure it's a valid solution and not an extraneous one because we're not dealing with imaginary roots. Okay, last one for the day. What do I need to do here? Add 2. Thank you for not trying to square it right away. So square root of 2x squared plus 1 equals 2. Then what? Square it. So we have the square, oh nope, the square root cancels out. So we have 2x squared plus 1 equals 4. Then what? Subtract 1 and we have 2x squared equals 3. Then what? Divide by 2. We have x squared equals 3/2. So what's our solution? Yeah, x equals plus or minus the square root of 3/2. And I'm 100% okay with us leaving answers like this. This is totally fine. If you look in answer keys, they will rationalize this, so there's no radicals in the denominator. So multiply by square root of 2 over square root of 2, and you get square root of 6 over 4. No, square root of 6 over 2, sorry. But I'm okay with us leaving it unrationalized. Okay? That's the last one for today. Okay, so for homework 2-5, we've done everything up to 18. Okay? So tomorrow we'll talk about, okay, birds. Like 3 people just whistled at that. So tomorrow we'll talk about the rest of it. Homework 2-5 is for Thursday. We're having another quiz on Friday, and our chapter test is next Friday. I know. Okay? We have 5 minutes. We have 5 whole minutes. All right, did y'all just figure out how to whistle or something? Like we just learned whistling?